Hello everyone. In this video, we are going to see yet another example for sum of product reduction of Boolean expression. We already seen one example how to use K maps for reducing, minimizing the Boolean expression, sum of product expression. So you are going to see one more example, okay, based on that. So you will see another question. Okay, so what is the simplified Boolean equation for the function f of wx yz? So you got four variables, so you should draw an four variable K map. Okay, and you got the four variables, so you have to label it accordingly. So you have to put wx in the left hand side and yz in the on the top and label it correctly and put the numbers, okay, minterm the boxes numbers correctly. Once the minterm numbers are put correctly, then you can fill up with the ones. Okay, so you can see summation of 7 9 10 11 12 13 14 15. So once these K map is ready, once the empty K map is ready, you are ready to fill up with the values, midterm. So you're going to fill up the values. So you can see that you have 7, then 9, 10, 11 and 12, 13, 14, 15. So you got 8 midterms available, and see that you fill up all the midterms. You can count the number of ones in the K map and check it, verify with the question. So if it is correct, then your answer will be correct throughout. Okay, so after filling up the number of ones, the remaining boxes you have to fill up with 0. So this is the first step. So first step is over. Now you are going to identify how many octet or how many chord or how many pass are available. So you have to always go for octet. So check for octet. Here you don't see any octet, so you are going for chord. You can identify the first chord here, okay, which is nothing but 12, 13, 15 and 14. So this is chord 1. So M12 plus M13 plus M15 plus M14. Okay. So this is chord 1. So since you have 7 ones, you got one missing here. So you cannot make it as an octet. So you can make it as a chord because no octet has been available here, right? Now, after marking chord 1, you may see 3 ones here and one here. So you have to go search for if there is any other possible chords available. Okay, instead of going for pairs, you have to go for chords. Check for any other chords available. You can see here, you can see 13, 15, 9, 11 can make a chord. You could look like a chord, right? You got 4 adjacent ones. So you can make a chord. So that will be marked, okay, and that will be chord 2. So 13, 15, 9 and 11, which makes chord 2. Then after marking it, you got 1 here and you got 1 here. So this cannot be marked as any chord because only you got 3 ones. But if you see this part, okay, this one can be joined with other 3 ones here. So this also can make a chord. Okay, so you cannot go for a pair here because after identifying all the chords, then only you are going to go for pairs. If no more chords can be identified or marked, then you are going to go for pairs. So here you can mark it as a chord, right? So it is 15, 14, 11 and 10. That will be the chord. So M15 plus M14 plus M11 plus M10, so which will make chord 3. Okay, now you got remaining one. So here you don't have any adjacent ones here, okay, except the 15, right? 7 and 15, which can make a pair. So you are going to make it as a pair. Okay, so you got pair 1, that is M7 and M15. So this is how you are going to identify. So first you go for octet. If there is an octet, immediately you can mark it and your expression will be in the simplest form. If there is no octet, then you have to go for chords. Find the maximum chords available. Okay, after finding the maximum chords, finally you are going to go for pair. If you go for pair before the chords, then you will end up with wrong expression. So this is how you are going to identify chords and pairs. So after this, your work has been simpler. You are going to reduce the expression. Okay, so first you are going to reduce the pair. Okay, so it is 7 and 15. So W dash, you can see W dash has been changing its state to W. Okay, so this W has been removed. X is same. Okay, and Y, Z is same for both the numbers. So you are going to take X, Y, Z for that is a reduced expression for pair 1. Now next is chord 1 here. okay, which is wx will be common for all the values, that is all ones, and you can see y dash and z dash will be always changing because you're going to take all the four boxes. So in one point you can see wx dash z dash is been changed to z, so z is removed. Second box and third box you can see second column and third column y dash has been changing its state to y, so always anyway it will be removed, so both the variables will be removed here, but wx will be constant for all the four boxes. So you're going to take wx for that will be the reduced expression for chord 1. Okay, now you are going to go for chord 2. Okay, say where you got w will be same because it is not changing its state. You can see x is changing its state to x dash, so you're going to remove x here, you're going to keep w, and on top you can see y dash is changing its state to y, so you're going to remove y, you're going to take z, so you will have the second chord expression will be w and z. Then the final one, okay, chord 3, where you have w again, it is constant, x is removed because x is changing its state to x dash, so it has been removed. Now you can take the third and fourth column, y is same, it is not changing its state, it is same, but z you can see it is changing its state to z dash, so you're going to remove z. Okay, so it will be w and y. Okay, so this is how you're going to identify the terms. Now finally, very simple, you're going to combine all these, okay, xyz plus wx plus wz plus wy. So this will be the final reduced expression, okay. So SOP form, this is SOP form, sum of products form, okay. So this will be the final answer for the question what has been asked. Okay, now you can try out two questions given here. Obtain a simplified expression for the Boolean function xyz, the k map for which is given below. So here in this question you can notice that k map is already given with the marking, right? You can see that you can see once it's been already been labeled. Here what you're going to do is you're going to identify you don't have octet anyway, you're going to find the chord or pairs and then finally write the expression. So this is the simplest form. So here you got only three variables, so since you have three variables you're going to draw only three variable k map. So based on the variables. So second question you can see, minimize the following function using a k-map. You can see four variables. So here this is what we already see. Okay, you are going to draw the four variable k-map, then the write the min terms and then fill up with zeros. Remaining boxes you can fill up with zeros and check for octet. Anyway, no, only four ones are there. So anyway, no octet will be available. So you're going to go for check for chords and finally go for pairs. After that, you're going to write the terms and then combine that and write the SOP expression, right? So sum of product expression. So hope you understood this video. We'll meet you in the next video. Till then, thank you.